which we don't know at 50 inches. We don't know what my new mass is going to be at 50 inches. That's unknown. That's x. So you're going to have x over here. You're going to have new mass over the x. And then D1 is the old distance, which would be 40 inches. D1 goes here, and I'm going to square it. So it would be 40 squared. And my new distance is 50 inches. So that would go here, and I'm going to square it, so it would be 50 squared. So I would have 40 squared over 50 squared, and then my old mass was 10 over x. Then you just have to solve it. You square these things and then cross multiply and solve for x. You can do it that way. I don't know, in my mind, I like to isolate x. I like to have x all on one side. It's just easier for me. If you like to cross multiply, that's your formula. But if you like to isolate x, that's it right there. So my new mass, which is the one I don't know, is x equals my old mass times my new SID over the old SID squared. That one is just easier for me. Either one will work. So I guess maybe you can tinker around with, I'm going to give you a worksheet here. You can tinker around with both formulas and come up with the one that works best for you. This formula right here, there's actually like 6 different versions of it. We're going to learn one this semester. We're going to learn the different versions in imaging too. We're going to get this one down for right now. Do you have that? Okay. I'm going to give you a sample question, just like what's on your quiz for next week. Okay, so we have our original SID is 40 inches. And 75 mass produced a 1.0 density, which is what we were after. We like, remember I said we like 1.0, that's like the best one. We had to pick one. We probably picked 1.0. Okay, so now it says, what new mass would you use at 60 inches? If you wanted to maintain the original density. So what we have is we have 40 inches is our old SID at 75 mass. Our new SID is 60 inches, and the unknown is the new mass to compensate. Okay, so once you recognize that this is the inverse square law, then it's just a matter of plugging the right numbers into the formula. The formula is really not that hard. It's just recognizing that that's the one you need to use. So I like to use that one, so all my examples have this. And then I plug everything in, and my new mass equals 168.75. Inverse square law. So that definition, like I said, I don't really expect you to understand the definition right now, but for the quiz next week, you have to have it memorized, because I'm going to ask you to define it. That formula, the words to that formula will, trust me, make sense to you one day. Maybe not today or next week, but eventually they will. Now, you got to go back and you got to look at the problem and see if it made sense. Okay, we were at 40 inches. We used 75 mass. We went to 60 inches. Now, I'm further away, right? What's going to happen to my beam intensity? Is it going to go up or down? Down. It's going to go down. So in my mind, what has to happen to my mass? Does it need to go up or down? Up. It's got to go up, because you want to maintain the same density. So when I look back at my problem, I started out with 75 mass, and I went to 168.75. That sounds about right. So I think I probably did the right thing. If this went below 75, you did something wrong, right? It shouldn't be below 75. It should be above 75. Okay? If it went below 75, you probably had these two reversed. Probably had the old on top and the new on the bottom. Okay? But like I said, this is the only version we're going to learn right now. So that's always the new is on top, new over the old. Okay, last one. Our original SID was 72 inches and 5 mass, produced a 1.2 density. What new mass would you use at 40 inches if you wanted to maintain the original density? Okay, so the first step is to recall the formula. And then plug the numbers in. And my new mass equals 1.5. Now, does that make sense? Well, I started out at 72, so I'm going into 40. So my beam intensity is going to go up. So to compensate, I need to go down in my mass. So I started out with 5 mass, and my answer is 1.5. Once again, that sounds about right. Okay. And I'm going to give you, and I don't have this up here, but I think it would help kind of give you some idea of how you ballpark the answer. I think that would be a good thing to kind of think about a little bit, is how you would ballpark it. So write down this technique. Write down this technique. So I'm at 40 inches, and I have 25 mass. And I'm going to go to 80 inches. So what did I do to my distance? I exactly what?
Doubled it?
Doubled it. Okay. And I want to know what my new mass is. Now, here's what I want you to do. And I don't want you to do it right now, but I want you to use this formula right here to figure out what the new mass should be. Okay? Use the formula. But if you exactly double your distance, this is how you kind of are going to start to kind of understand how you ballpark it a little bit. If you double your distance, you don't even need to use this formula. You double the distance. All you need to do is multiply your mass times 4. You're going to use 4 times more mass if you double your distance. So the answer, I already know the answer is 100. But I want you to use the inverse square law formula and see if you come up with 100 too, just to prove that it is 100. So if you double your distance, it's 4 times your mass. Okay, so what if I started out with this technique? What if I started out at 80 inches and 100 mass? And my new distance is going to be 40 inches. What's my new mass?
25.
It's 25. So if you cut your distance in half, what do you do to your mass? Divide it by 4. Okay? If you double your distance, multiply it by 4. If you cut it in half, divide it by 4. So you guys can go back and use the inverse square law to prove that. Let's just take a little quick peek at this formula, this handout that I gave you. This doesn't happen